Belt Series supergroup is a series of sedimentary formations throughout the Northwest, specifically in Alberta, British Columbia, Montana, Idaho, and Washington. The Belt Series can be seen in northern and central parts of Idaho. The basin was part of a 1.45 GA supercontinent that predated Rodinia. Rodinia is a hypothesized supercontinent which contained most or all of Earth's landmass. According to plate tectonic reconstructions, Rodinia existed between 1.1 billion and 750 million years ago, in the Neo-Proterozoic era. The Belt Basin shows evidence of these basin-bounding faults on all sides, except the west, which drifted away in the breakup of Rodinia. The reason we study the belt rocks in the area is to gather a greater understanding of the Proterozoic sedimentation process that took place during the breakup of Rodinia and for the past billions of years. The correlation of faulted and folded blocks allow the piecing together of the history of tectonic adjustments. Locating the ore deposits are valuable to economic goals of Idaho business and business in the Northwest United States. To understand more about the Belt supergroup, we need to first learn about the sedimentary types in its geological province and how they formed. The sedimentary rocks found in the Belt series are from the Mesoproterozoic geological era, which occurred about 16 to 1,000 million years ago. It is formed in a Mesoproterozoic intercratonic rift environment. This was regarded as the first respectable period of Earth's history for geological studies because before that, in the Archean and Hadean age, in which microcontinents were colliding to make supercontinents, there are very few reliable rocks which can provide accurate dating. In this supergroup, there are mesosediments, which are a huge sequence of sedimentary rocks that metamorphize, which can be 15 to 20 kilometers thick. An example of these metasediments can be seen in the Glacier National Park, located in the state of Montana, which also goes into parts of British Columbia. A specific strong example of this is in Chief Mountain. In the photo, you can see the layering in rocks. The rocks are metamorphized and sedimentary. This specific mountain is unique because the old rocks are on top, which violate the law of superposition. This occurs for three reasons. First is the sedimentary rocks accumulated in this basin in this order. Second is the thrust faulting from less than 100 million years ago. And finally is glaciation. Another major characteristic of this supergroup is the cratons or shields, which are large stable blocks of Earth's crust forming the nucleus of a continent. They formed as a result of the formation and breakup of supercontinents over billions of years ago. The images you are seeing now are from a PowerPoint by Jim Cash at the digital geologyofidaho.com. These images show you various metamorphic rocks correlated with the Belt supergroup in Idaho. Among other examples of sedimentary rocks in the area are gravel, sand, mud, silt, and carbon sediments, which can be from anywhere from 1470 to 1700 million years old. According to Professor Don Winston of the University of Montana, the sedimentary structures of these rocks are beautifully preserved since they were deposited 1.5 to 1.4 billion years ago. And locally, in Montana, they reach more than 18 kilometers thick. The silt is hummocky and plain laminated and are found near lake bottoms. The gravel found in the Belt series is cross-bedded pebble quartzite and feldspathic conglomerate.
Among the major structural features of this geological province are the Ravalli group, Piegan group, and Missoula group. The Ravalli group is subaerial, containing deposited sands and muds, mostly fluvial from the west. The Piegan group is the middle belt carbonate muds alternating with lamina of clastic muds. The Missoula group is a deposition of sands and muds, similar to the Ravalli group but from the south. These subgroups run through towns in Montana, and they affect the everyday life of those that live there. The lower belt, the last part of the supergroup, is known for its fine-grained, clastic to carbonate rocks, mostly subaqueous. Deep water deposition, there is also an abundance of fine-grained sand, as well as cyclic and rhythmic deposition in the Mesoproterozoic basin. Packages of the sedimentary rocks are deposited in Mesoproterozoic basin over the portions of Alberta, British Columbia, Montana, Idaho, and Washington. Near the Washington border, the thickness of the formations can be 50,000 feet thick. What is interesting to note is that the sediments abruptly end up where the basin splits. The other half is believed to be part of either Australia or Siberia now. The natural resources that can be found throughout the belt series, not just Idaho, are ore, silver, lead, zinc, and copper. While there is not much mining occurring in the south of Idaho, there is a lot more in the north. For example, Coeur d'Alene has a mining district in Panhandle of northern Idaho, mining with the basin itself. Also much more common up towards the Canadian and Washington border. Earthquakes are also very possible in this mountainous region due to the relevance of plate tectonics and faults. Since the belt supergroup is important to the geology of Idaho and life as a whole, it is of utmost importance for us to study it and understand it, not only for the sake of geology in Idaho, but in the Northwest as a whole.